Saxon Algebra 1, Lesson 33. We have two topics in this lesson: products of prime factors and statements about unequal quantities. A counting number that can be written as the product of two whole numbers that are greater than 1 is called a composite number. For example, 6 is a composite number because it can be written as 2 times 3. 12 is also a composite number. It can be written as 2 times 6 or as 4 times 3. A counting number bigger than 1 that is not composite is called a prime number. The first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These numbers cannot be written as the product of two whole numbers greater than 1. Every composite number can be written as a product of two or more prime numbers. For example, 12 can be written as 2 times 2 times 3. These are called the prime factors of 12. A composite number can be factored into the product of its prime factors by systematically dividing by prime numbers, as the following example illustrates. Express 252 as the product of prime factors. We start with the smallest prime, 2, and divide. 252 divided by 2 is 126. 126 can also be divided by 2, so we do that, and we get 63. We can no longer divide by 2, so we try the next prime, 3. 63 divided by 3 is 21, and 21 divided by 3 is 7. Now 7 is a prime, so we can, at this point, stop and write the prime factorization. The first number we divided by was 2, so 252 is 2 times another 2, because we divided by 2 again, times 3, we divided by 3, times another 3, and then times 7, the prime we ended with. So there's the prime factorization of 252. Another example. Give the prime factorization of 525. 2 does not divide into 525 evenly, so we start with the next smallest prime, 3. 525 divided by 3 is 175. 3 doesn't go into 175, so we move to the next smallest prime, which is 5. 175 divided by 5 is 35, and 35 divided by 5 is 7. Again, we arrive at a prime, so now we can write the prime factorization of 525. It's equal to 3 times 5 times another 5 times the 7 we ended with. There you have it. Now we consider statements about unequal quantities. Often a word problem makes a statement about quantities that differ by a specified amount. Such a word problem might state that one quantity is a certain amount less than another quantity, or that one quantity is a certain amount more than another quantity. To solve such word problems, we need to translate them into an equation about quantities that are equal. For example, if a problem says that the cost of a new TV is $20 less than the cost of an older TV, which is on sale for $360, then we would subtract the $20 from the $360. The cost of the new TV is $360 minus the $20. If X is the cost of the old TV, then we could write cost of the new TV is X minus 20, and not 20 minus X. If some quantity is 20 less than X, then we write X minus 20. And if a quantity is 20 more than X, we write X plus 20. Problem 1. Twice a number is 20 less than 360. Find the number. Twice a number is 20 less than 360, translates as 360 minus 20. The 20 less than has to be subtracted from the 360. So 2n is equal to 340, and that gives n is 170. Let's check this, make sure it makes sense. Twice 170 is 340, and 340 is 20 less than 360. So it does make sense. Problem 2. Twice a number is 42 less than negative 102. Find the number. This is similar to problem 1, except it has a negative 102 in it. Well, twice the number is 2n, and is 42 less than negative 102 means we write negative 102 minus 42. You see, the 42 less than is what's subtracted. So we have 2n is negative 102 minus 42, or 2n is negative 144. Divide by 2, we find n is negative 72. Again, we will check. Twice negative 72 is negative 144, and negative 144 is 42 less than negative 102. Negative 102 plus negative 42 would be negative 144. Problem 3. 5 times a number is 72 greater than the opposite of the number. Find the number. Well, 5 times the number is 5n, and that is 72 greater than the opposite of the number. The 72 greater means we're adding 72, and we're adding that to the opposite of the number. So we have 5n is the opposite of n plus 72. Now we can solve the equation. Let's get rid of the minus n on the right. We'll add positive n to both sides. That gives us 6n is 72. Divide by 6, we find n is 12. Let's see if this makes sense. 5 times 12 is 60. And the opposite of 12 is negative 12. And 60 is 72 greater than negative 12. We add 72 to negative 12, we get 60, so it does make sense. Problem 4. Twice the sum of a number and 17 is 15 less than the product of the number and 3. What is that number? Well, let's see. We have twice the sum. Twice the sum. When we multiply a sum by something, we must enclose the sum in parentheses. So it's twice the sum of a number and 17, 2 parentheses n plus 17. And that is 15 less than something, so we're going to subtract the 15. It's 15 less than the product of the number and 3. That means the number times 3, or 3n. So there's our equation. 2 parentheses n plus 17 equals 3n minus 15. We need to distribute that 2 over the parentheses on the left. That gives us 2n plus 2 times 17, which is 34, equals 3n minus 15. Now we have n on both sides, so let's subtract 2n from both sides, and that gives us 34 equals n minus 15, and we can add 15, and we get 49 as the value of n. Let's check this. Twice the sum. The sum of 49 and 17 is 66, and twice that, twice 66, is 132. The product of 49 and 3 is 147, and 15 less than 147 is 147 minus 15, which is also 132. So we are getting the same result there. This is the end of Lesson 33. Your assignment, problem set 33 on pages 137 and 138 of your book.